Oh, four of us in class today, I guess.
Well, three of you.
Yeah,
Count,
yeah, four total, three students. Wow.
That's okay.
Oh,
That's okay. You know, they're hopping on now.
yeah.
Okay, so today we're gonna see pillar 5, which is the last one of the well-architected framework, and number 5 is cost optimization. All right, there are many things here in this module that we already saw in class, guys. So it's not gonna be a long module. All right. So, and if you already took the cloud practitioner, there's so many concepts that were talked about in that class or for that certification. Okay. So, what's in this module? Part 1, the principles of cost optimization pillar. Part 2, optimizing the cost of your infrastructure. Part 3, dedicated instances and dedicated hosts. Part 4, trusted advisor. Part 5, optimizing costs with caching. And part 6, AWS cost calculation tools. We're gonna have an exercise, which is like we've done so far. We've been doing so far, improve this architecture, and some of the questions that some people may have when it comes to this pillar. So upon completion of this module, you will be able to understand the principles of the cost optimization pillar, discover how to optimize the costs of your infrastructure, and follow best practices to eliminate unneeded costs and suboptimal resources. All right, so let's see the principles. So here, you know, what it tells you is, that you're gonna have the ability to avoid or eliminate unneeded costs and suboptimal resources. You're optimizing the cost, right? So you're looking for solutions that are cost effective. That's very important. Like I've said before, sometimes when you talk to someone, a business owner, and you put these ideas of migrating to the cloud, one thing that they're going to look for is cost. That's very important because you know it's a little painful to move all your infrastructure to another platform. So they have to make sure that it's worth doing that. And one of the things that they consider is cost. Okay, so you have to find resources that are cost effective, right? We have many resources that, for example, for servers or for doing computing, you have EC2, you have Lambda, and you have to see which one is more cost effective, right? Um, I think it all comes down to the needs of the business more than anything. I cannot say that Lambda is cheaper than EC2 instance. It depends on the needs of the, you have to study what the business needs, and then you can get to a conclusion. Because it's true that Lambda doesn't need servers, and that's a lot of money that you're saving, you know, on maintaining, on patching, on people that will work with the servers, like administrators and all that. But there may be some situations when EC2 is cheaper. So you have to, study the business first, what they need actually, right? Matched up supply and demand. That's very important. We have to be provision, not under provision or over provision. That's very important. Expenditure awareness. So when you have this pillar, you are aware of your expenses. So how much money you're expending, how much money you will expend in the future, like a you know, projected expenditure. Like when you use, for example, Cost Explorer, it's going to tell you how much you're going to expend in the next 3 months, right? And then you can go back up to 30 months to see how much you'll spend in the future, in the past. I'm sorry. And optimizing over time. So like I said before, the projection in the future, how much you can optimize your resources. So design principles. You have to adopt a consumption model. So you can pay only for the computing resources that you consume, and increase or decrease usage depending on business requirements. So it all comes down to the business, right? What the business requires, right? Sorry about this. So you're not gonna use elaborate forecasting. It's gonna be projected. For example, development and test environments are typically only used for 8 hours a day during the work week. You can stop these instances of the resources when they're not in use for a potential cost savings, probably 75% or 40 hours versus 166 hours, right? So 168 hours, I'm sorry. So, like it happened in the project that some students left the services running, right? And you were charged some money. Um, if those services had been stopped, no money would have been charged. So that's what happens, as exactly what happens in the business, right? If you have instances running and you're not using them, you're going to be charged for those. So that's not at all cost optimization. So you need to optimize the cost by stopping all the instances that are not running, that are not being used. I'm sorry. Okay. So measure overall efficiency. You can measure the business output of the system and costs that are associated with delivering it. You can use this message to understand the gains you make from increasing output and reducing costs. So that's very important. Stop spending money on data center operations. This is something that we already talked about. This one, or very similar to one of the 6 benefits of the cloud, like a stop spending money on servers capacity. You don't need that, right? Analyze and attribute expenditures. So you know that the cloud makes it more straightforward to accurately identify the usage and cost of the systems, which then allows transparent attribution of IT cost to individual business owner. So this particular principle helps measure return on investment. So that's important for every single business, right? And it gives the system owners an opportunity to optimize their resources and reduce costs. Right? Now, the last one, use managed services to reduce cost of ownership. In the cloud, managed services remove the operational burden of maintaining servers for tasks like sending email or managing databases. And because managed services operate on cloud scale, they can offer a lower cost per transaction or service. So I think that we are spinning around the same topic. When it comes to cost, they always talk about servers and the cloud, that you can scale up, scale down, scale in, scale out, all that. And by doing that, you're saving tons of money. And we saw some of the um, some of the services that help you do that, and in the cloud practitioner class, and also we have talked about that in this class as well. Okay. So key services for cost optimization areas, cost-effective resources. The key services are reserved instances. When you reserve instances, remember it's 1 year or 3 years, right? And you can save up to 75%, which is a high percentage savings. And we have Cost Explorer, with this already before, talked about this guy before. Match tab supply and demand, auto scaling, it's the guy that works with that, less servers, scaling, more servers, scale out, expenditure awareness. We have Amazon CloudWatch. With Amazon CloudWatch, you can create a budget, you can create a billing alarm, all the things that will tell you what's going on if you just went beyond your budget threshold. Amazon SNS is the guy that works with Amazon CloudWatch to notify you of any charges or any events that have taken place based on, about cost optimization. Optimizing over time, they have this guy, what's new, AWS blog. So you can check this. This is available to everyone, right? I think there's a section where you can subscribe to receive what's new in AWS. And trusted advisor here, this is the expert in the cloud that will help you with the cost optimization as well. They have like different points that they like service limits, like cost optimization, security, reliability, all those guys. They will give you, recommendations on that, right? So optimizing the cost of your infrastructure, part 2. This is something that you already know, guys. You get hands-on experience with AWS Cloud Services. We use 12 months, for the free tier account, right? And of course, the free tier account has certain limits, that. Tell me about it. So use other free options like the AWS free tier eligible software, AWS free tier non-expiring offers. This is something that you can see as well, right? Okay, so the pricing options, this is something that we already saw as well. How Amazon or AWS charges you when it comes to instances, right? So on-demand instances is a spot instances, a reserved instances is per second billing. Oh my God, I cannot touch this mouse. This is so sensitive. So per second billing is Amazon Linux and Ubuntu only, and per hour billing is all other operating systems. And dedicated instances and dedicated hosts is per hour billing. Okay. Now, there's a new. I mentioned it in the Product Cloud Practitioner class. There's a new purchase option, savings plans. It's a new service. I think that it came out in October, I think. So this one, I don't know if it is in the exam already, but just in case, guys, remember this guy. And I will tell you about it. It's a flexible pricing model that provides savings up to 72% on your AWS compute usage. This pricing model offers lower prices on Amazon EC2 instances usage, regardless of instance family, size, operating system, tenancy, or AWS region. And also applies to AWS Fargate and AWS Lambda usage. Savings plans offer significant savings over on-demand, just like EC2 reserved instances, in exchange for a commitment to use a specific amount of compute power measured in money per hour, for a 1 or 3 year period. You can sign up for savings plans for 1 or 3 year term and easily manage your plans by taking advantage of recommendations, performance reporting, and budget alerts in the AWS Cost Explorer. All right. So if you Google Amazon EC2 purchasing options, I'm sure you're going to find all these guys, including savings plans. All right. When I took the exam about a year ago, savings plans was not an exam. This is something that came up a little later. Okay. So Amazon EC2 instance on-demand instances, guys, you know that already. You pay for compute capacity per second, Linux, or by the hour on all other operating systems. No long-term commitments. This is for unpredictable, right? Unpredictable spiking of EC2 instances and the traffic. There's no upfront payments for on-demand. The only one that takes upfront payments, which is optional as well, is reserved instances, right? So you can go all upfront, or full upfront, partial upfront, and no upfront. So increase or decrease your compute capacity depending on the demands of your application, and then you'll see auto scaling is going to be there to match up the supply and demand. Okay. So Amazon EC2 on-demand instances recommended for users who want to low cost and flexibility of Amazon EC2 without an upfront payment or long-term commitment. So this is without interruption. Don't forget that. The one that is for interaction is the one that can be interrupted is spot instances. So this one is for short-term, spiky, and unpredictable workloads that cannot be interrupted. That's very important. That's the use case, right? It cannot be interrupted. It's unpredictable and spiky and short, right? That's what usually happens when you have, let's say, a lot of sales on Christmas or Thanksgiving or July 4th. You know, those days. That's when on-demand instances come in. You know, if you have them, of course. Applications being developed or tested on Amazon EC2 for the first time. So if you want to test your system, your application, on-demand instances are very useful for that. Right. So spot instances, you guys already know that this is bidding. You are bidding for unused capacity that AWS has, right? Spare capacity. And then you put a bid on it, and then you're gonna use it as long as your bid is not our bid, okay? So the price is controlled by AWS based on supply and demand. You know, it may increase, and when there's gonna be a termination, you're gonna have 2 minutes to move fast and do whatever you have to do to save your data, right? Because in 2 minutes, your EC2 instances are gonna be terminated. So that's very important for EC2 instances are spot, right? You know, you should have some backup in place. You know, if you're using spot instances, that's the wise thing to do. Because, you know, in any minute, your instances can be terminated. That's the way it is, guys. Some students have expressed some displeasure with that because it doesn't make sense, you know, in an actual auction, when you bid and no one outbids you, you get the item, you go, it's yours, right? It's not the same with AWS because actually you're renting a platform. You're not, the platform is not yours. So you are bidding on a spot instance, you're the winner, right? You get it, use it, but still it's not yours. It's AWS's. So as long as the bid is not, outbid, you can keep it, right? That's very important. So in spot instances, you can interrupt them, you know that, and you can hibernate them, stop or terminate spot instances when they are interrupted. So difference between this and on-demand, in on-demand cannot be interrupted, spot instances can be interrupted, all right? Best approach to temporary requests for large numbers of servers. So if you need a large capacity of servers, the best approach is this one, EC2 instances, spot instances, all right? So you can have a spot fleet, which is a collection of spot instances that is launched based on criteria that you should specify. So when you create, for example, you create auto scaling, and then you create a launch configuration, you can specify that you want spot instances, and then based on that specification, you're going to have a fleet. So you can put 2 or 3 or 4, depending on the desired capacity, the maximum capacity, minimum capacity. That those spot instances are going to be created. Now, when it refers to a group of EC2 instances, the term that's used is fleet. Okay, you can say a group of EC2 instances, but a fleet is the most common term when you refer to a group of instances. Okay, the use cases for this, for example, batch processing, generic background processing, scale-out computing, web data crawling, analyze data, financial hedge fund analytics, energy trading, etc. Amazon EMR, Elastic MapReduce. Which this is for large data processing, Hadoop, grid computing, scientific trials or simulations in chemistry, physics, and biology, transcoding. For this particular use case, we use Elastic Transcoder, which is to modify and convert media file from one format to another one. Okay. Gaming, backend servers for Facebook games, testing, scale to large server pool to test software, websites, etc. So spot instances is also used for testing. They're also used for testing on demand and spot instances, depending whatever your business has decided. But these are some of the use cases when you use spot instances, right? Always keeping in mind that your instances can be terminated at any minute, okay? So that's very important to know. But you're gonna get a notification 2 minutes in advance. So it's a short window, but you should have a very good notification system that will tell you that your EC2 instances will be terminated. Or if you already have a backup system in place that is already backing up all your instances on a daily or hourly basis, you don't have to worry about that. The instance can be terminated. Don't forget that instances are treated as stateless. It means that when you have another scaling group and you have all the instances, they are the same. They have the same launch configuration. So it doesn't matter if you lose one or lose two, another one will be created based on the configuration. So if you are all set up, you have your backups, everything is ready. I mean, you don't have to move fast or wary if you get that notification, okay? So reserve instances, I think that's the easiest one of all. It's very straightforward. You can have no upfront, partial upfront, all upfront, okay? So what happens when you have no upfront? You get the least discounts. You can have 1 year or 3 year term, standard or convertible. Standard, it's those that you don't have to convert, but convertible are the ones that, for example, in the middle of the process, you want to change to a smaller size or a bigger size, another family or something, you can do it because it's simply convertible. Okay. Partial upfront. This is the second most inexpensive one. And expensive, I said expensive because you save more money than no upfront, right? And less money than all upfront. That's why I said the second most inexpensive. So part of the reserve instances might be paid at the start of the term. Of course, is partial upfront, right? And 1 year or 3 year term, standard or convertible. And something very important, what happens if you decide to not use this anymore? Because let's say that your business goes out of business, 6 months later after you reserve this. Well, what happens when you rent or lease a car and then you lose your job? What are your options?
You can sell the instances.
I'm sorry?
You can sell the instances on the market.
That is correct. You can sell that, and if I remember well, you're gonna be charged a fee. I think it's 25% of the upfront fee. I think that is okay. Yes, I read it a while ago. You charge for that because you are terminating your contract in the middle of the process, even though you're selling your instances, right? You can sell your instances and people will buy them, right? And you will lose money because probably you can sell them for less money. I don't know. It depends on how much you sell them for, okay? But The reason, I mean, the answer to the question, can I get rid of the instances if I terminate, or if I want to terminate this contract? Yes, you can sell them. Simple, right? All upfront is full payment made at the start of the term. Okay. This is even more, you have to be sure that your traffic is predictable, right? Throughout the year, right? You have to know this, because in this one, you may lose more money if you terminate the contract, right? Because you're paying all upfront. In partial upfront, you're paying only half, or probably 30% or 40%. I'm not sure what the deal terms are, depending on what deal you're getting, right? And what agreement you get to. But this one, you may lose more money, right? Because you're just giving away all your money, or you're paying all your money all front. No other costs incurred for the remainder of the term, regardless of usage. So you can use as much as you want, and I believe that all this is calculated based on your business patterns, how the traffic pattern is throughout the year, right? And then 1 year, 3 year term, standard or convertible, same thing. So with the three different reserved instance types, you can have standard and convertible, okay? The convertible reserved instance, you change the instance family and other parameters associated with the reserved instance at any time. So in other words, you are modifying your instance anytime within that term. Even 1 year or 3 years, you can modify either the instance family. You have the T2 micro, T3 micro, you want to change it to an X5 large, whatever, you can change that, right? And there's no limits for that, right? So you can go from the least expensive one to the most expensive one. Of course, you're going to be charged for that, right? Because you are increasing, the capacity of your instance, right? That's not what you agree at first, right? You purchase convertible, but in the middle of the process, you may convert it, and then you may incur some charges, right? Used to take advantage of EC2 price reduction over time. You can save money over time, and there's no cost for this conversion as long as it is the same in the same section. Or if you can agree at the beginning, the conversion can go up to this family type, then you can have that, right? Because when you start something, you may not know what's going to happen in the future. So you start with one price, but then you may increase the capacity at a certain point, so they may charge you. But probably you're a smart person, and then you believe that your instances may grow or may require more power in the future, then you can buy convertible that can handle that capacity, okay? And that's the moment when you don't get any cost. Requirements: convertible reserve instances must be active and must be not pending any previous exchange request. Okay, so when you make an exchange request, you can make another exchange request until that one is not pending anymore, right? So that's with what this piece of information is telling you.
So is this, good afternoon.
Yes.
Is this only for making changes up, not changes down, or how does that work? Since you're reserving.
No, any type of request, change request. It could be up or down. Okay, one moment. Okay. There's certain requirements. You see, you can exchange one or more convertible reserve instances for another convertible reserve instance with a different configuration, including instance family, operating system, and tenancy. There's no limits to how many times you can perform an exchange as long as the target convertible reserve instance is of an equal or higher value than the convertible instances that you are exchanging, equal or higher, right? When you exchange, but it says higher value, right? So when you exchange your convertible, go ahead, Maria.
So let me see if I understand what this is saying. So let's say you have a large, right? No, I'm sorry, an extra large. EC2 instance. And I want to exchange it for 2 large ones rather than 1 extra large. As long as this is the equal or higher value, as long as the value is the same, is that going to work regardless of how many instances I'm exchanging for?
Okay, but it says
I don't
here,
know if I'm explaining myself correctly. There was a case in one of the tests, for example, that says something about a large not being able to accommodate, and then he said in that scenario it was asked, the answer was to move up to an extra large. But I'm saying, why not add more large instances, right? Or maybe exchange the extra large for more large instances that you can distribute the load along that.
I know what you mean. So you're talking about the same value, but different quantity.
Same value, but perhaps a lower capacity instance, but more of them. But then at the end, the value will be the same.
Well, it says here you can exchange one or more reserve instances for another convertible reserve instance for another, not for other. So that is something that is a good question. To exchange a portion of a convertible reserve instance, you can modify it into 2 or more reservations. Okay. One moment, please.
Mm-hmm.
Okay, one moment. I was trying to close the door. Because all the words were. So that's a good question, Maria. Let me, because I thought the way I understood it before is that you can get an equal one or higher value, like another instance family with the same value, right? Like let's say that, let's say we have here the instance types. Instance types. So we have all these guys here. You can get, for example, you have one medium, for example. Probably you can get one large, but it has less capacity than this one. Let's say that this one has 30 gigabyte and this one has 8 gigabyte. So it's, the value is going to be similar, depending, it's just an example, right? So you can have equal value or higher. So it doesn't matter the instance type, it's just the value, okay? Now, That's a good question because I never saw it that way, that maybe you can have two mediums and exchanging for one large, or one large and exchanging for 2 mediums. That's a good question. So when I'm reading this, and Maria, I see that you're looking for that. If you find something, let us know. You can exchange one or more convertible. Guys, what do you understand by this when you read it? What do you understand by this? What do you understand by this?
So to me, just reading that, it looks to me that you can go down on the instance because it says
Yeah, you can go down.
so
Yeah.
it says a different configuration, including instance, family, operating system, and tenancy.
Yeah.
No, it says it has to be of an equal or higher value.
That's right. So the instance type doesn't matter. It's just the value.
So how many times?
Yep.
As long as the target convertible is of equal of higher value. Value meaning money, or
Yep.
value meaning
Yeah,
time?
value is money. Yes.
Okay.
Yes, that's what I said to Maria the first time when she asked me. You can scale in, right? You can go down. You know, scale down, not scaling. Scale down. Yeah, that answers the question, but partially, not completely.
Exactly. Yeah. To me, it seems like it's. I would have think that there will be instances where maybe just one doesn't do. Maybe you want to have two or three of a lower type, and then distribute the load because it gives you that capability as long as you're within the parameters of your application or what you're doing.
Okay, it says here, Amazon EC2 calculates the number of reserved instances that you can receive as a result of the exchange. So
the number of reserved instances, okay.
So probably when you change, it will tell you if you need another one. Let's say that you're changing from, you're going down from an X large to a medium, right? But that may not be, they may not match the value, right? So it may tell you need another medium to match up the value. So that's probably what this says here, if I'm understanding correctly. Okay, so Amazon EC2 calculates the number of reserved instances that you can receive as a result of the exchange.
So it looks like you can. It's just that you have to match it money to money or value to value.
I mean, it can be, the way I read it, it can be a smaller instance.
Yeah.
It has to be more powerful because the smaller instance is not going to have the same value as the one you're trying to sell or exchange.
For example, this one, if you have this one and this one, obviously this one is more powerful, right?
Yeah.
But what if you have, let's say, 4 GB here and 30 here? So there might be some difference there, even though this is a large, right?
Mm-hmm.
But it's a very tricky question because there are a lot of factors that take place there. Because this is a large, right? That's a large, and this is a medium.
2 CPUs.
Yeah.
But the way that I see this environment, right? It's that you can, because of the fact that you can distribute your load. I will say, if you can have more of the lower instant types, depending on your needs, then maybe it's more advisable because of the fact that you can distribute loads.
Yeah, but it gets to a point of how long, I mean, you're trading performance for cost. So it gets to a point that you might be better off keeping a slightly larger instance than 2 smaller instances. You might be better, more beneficial and less headaches as far as setting up and configuring and monitoring and all that.
But what happens if that one goes down? What
No,
happens if,
I know what you're saying, but you would obviously have more than one. The same thing as the smaller ones. I mean, if you have two small ones to run something, you're gonna have to have two more small ones to be redundant, to be fault tolerant.
but it's gonna cost you more?
But it all depends. I mean, is two smaller ones less expensive than one larger one?
I don't know.
Okay, here, this kind of answers the question. You can merge two or more reserved instances into a single reserved instance. For example, if you have 4 T2 small reserved instances of one instance each, you can merge them to create a 1 T2 large reserved instance. For more information, see support modifying instance type. So you can have 4 and change it to 1 large. I believe that you can have 1 large and change it to 4T, to micro, T2 small. The opposite direction, right? But there are a lot of things that take place here, where availability zoning was created. For example, here 10 instances in East 1A and 5 in the East 1B. Two new reservations, one for 5. This is so complicated. I mean, it's a mess. So you have to be careful when you do this, right? But here's telling you can convert 4 T2 small to 1 T2 large, which I don't recommend. It's like Maria said, you know, you're not highly available with this, unless you create another one within another scaling group, right? But you know, you have 4. It's less. I mean, 4 is more overhead than 1. But don't forget that this is not highly available if you have only 1. So you have to create another one, at least another one. All right. So to answer this to your question, Maria, and by reading this, I understand that you can go from 4 small to 1 large. And I'm sure, believe that you can go the opposite way.
What is that link? Support for modifying instance sizes.
Where's that?
Right there.
So you cannot modify this 4 because it has only 1 size.
You cannot modify the instance size of reserved instances for the following instances.
It says that you cannot modify T2 and T2 to a T3,
Interesting.
whether you use the same size or a different size, T2 to the T3.
So there is some.
Yeah, I can put this link here if you want.
This was part of the questions in the tests, the knowledge review.
Oh, with the digital cloud?
Yeah.
Did you read the explanation?
Yeah, but it was going up, not going down. And I said, what happens if I want to go down? If I want to increase, you know?
That's the easiest one. Going down is the easiest one.
So,
Yeah. As long as you keep the same value or more or higher. On-demand versus reserved instances, M3.X large, 1 year on-demand versus reserved instances. Maybe the question is, what are the break-even points of these various reserved instance purchasing options compared to purchasing on-demand instances? So let's look at this following scenario. You decide that you need an M3.X large instance that runs Linux and is located in the US East region. You wonder what the level of the usage or the number of hours in a month that you will run the instance. That's why I was saying before, It depends on, how much you're using it. What are the capacity of the EC2 instances that you have? What are the business needs? There's so many factors that come into place when it comes to these reserved instances. So does it make sense to purchase a reserved instance, or should you purchase an on-demand instance? So in this scenario, if you're running the instance at least 60% of the time, you will begin saving money by purchasing all upfront reserved instances instead of on-demand instance. But if you're not in a position to purchase an all-front reserved instance, consider the partial upfront reserved instance or no upfront option, where the break-even points are at approximately 65% usage and 72% usage respectively. Okay, so that's what business consider, right? In other words, if you run the instance at least 65% of the time, you cannot make an all upfront instance purchase. You will save money over the year by purchasing a partial upfront reserved instance. Okay. Now, if you rather make no upfront payments at all, but can commit to running the instance at least 72% of the time for at least a year, the no upfront reserve instance payment option allows you to pay a low monthly fee to take advantage of savings over using an on-demand instance. So it's very easy to say, okay, let's go all upfront to save money. No, it depends on your scenario, what you have. For example, what I just said, that if you make no upfront payments at all, but you can commit to running this instance in this graphic at least 72% of the time for at least a year, then no upfront is the option to go. And then you're going to get a very low monthly fee and take advantage of the savings over an on-demand instance. So you have to sit with the person that's in charge of the business operations. You have to sit with that person and understand the business, their needs, and their projected traffic during the year. If how much they think the traffic's gonna be projected throughout the year. That's very important. So there's no 1 + 1 makes 2 here. It all depends on the needs of the business. So I'm repeating the same thing again. Every case is different, right? Every case is different. There may be parameters that are similar, right? Steps that are similar, steps to make. But every business is different, right? Every scenario is different. So you have to, if you're an architect, a solutions architect, you have to study, you have to, get informed, review the documentation from AWS, seek help from other colleagues, try to instruct yourself on the steps that you're going to make towards the success of this business when it comes to architecting. So that's very important. Don't just think, oh, this is what I learn in class, this is what I do. No. You have to, based on the business, then you act, right? And then you do what you're supposed to do. So that's very important.
So this graph here, right, is showing that your break-even point between on-demand and reserve is between 60 and 70%. But that's assuming that you have data for a whole year for you to decide whether or not this makes sense.
Correct. Remember, this is
sorry. So if your utilization goes up and down depending on the month or the week or the season, or let's say in the spring you use it more than you use it in the summer, right?
Yeah.
Just thinking in terms of a pattern during the year, then you have other types of capabilities to be able to cope with the demand without having to go reserve.
Correct. That is correct. Right. So it just depends. You sit with the people in charge of this, ask them, how's your traffic throughout the year? Oh, we have more traffic. Our traffic is mostly in, during holidays, things like that. Then you can use on demand. But if your traffic is, it's over 60% or 65% throughout the year, then you can go with different the purchasing options for reserved, right? But it depends, right? Because we have on demand here. The on demand is just this one, orange, that goes from 30% to 100%. It's unpredictable. It can happen somewhere here, right? It may be down, maybe up. It's not predictable, right? But you said the reserve ones. You see how right here. You see the breaking point here, right? So you just have to compare side by side which one is more suitable for this business. On demand, reserve instances. But I believe that, guys, when you get to this point, you sit with someone and discuss these options, I believe that you're going to you're already at a level that you understand this much, much better than now, right? But breaking point is important. You know that everything is about cost, right? Everything is about cost. Reserve instances marketplace, flexibility, right? You sell your unused Amazon EC2 reserve instances. That's what Olivera said. You can sell it in the marketplace. You can buy, because just like you're selling, there are other people selling as well, right? You can buy from there, from other AWS customers. You can change your reserved instances as your needs change, right? Convertible. Diverse term and pricing options. Shorter terms. Opportunity to save on upfront pricing. Identical capacity to reservations. In this case, reserved instances from the reserved instance marketplace offer the same capacity reservations as reserved instances that are purchased directly from us, or from AWS, right? So other people, they offer the same capacity as AWS. Of course, they originally got it from AWS, because AWS also sells in the marketplace, right? Schedule instances, very easy as well. Reserve instances of predefined blocks of time on a recurring basis for a 1-year term with prices that are generally 5-10% lower than the equivalent on-demand rates, right? So the fact that you said reserve instances, it depends on, like we said before in this graphic, you may say, oh, reserve, I save more. No, it depends on the traffic, right? It depends on, okay, I can save up to 75% if I get reserve instances and pay all upfront. Okay, that's good. You're saving 75%, right? A lot of money. But how's your traffic? Is your traffic is your traffic enough for reserve instances throughout the year? Or your traffic is predictable? Unpredictable, I'm sorry. Is it unpredictable or predictable? So if it is unpredictable, then what you need is on-demand instances. So that's something that you have to take into account. Okay, so basically, schedule instances is when you have to stop your instances, for example, at every day at 5 p.m. You schedule it for them to stop at 5 p.m. every day, right? But you can do the same with the spot instances, right? They can be interrupted, right? But schedule instances are reserved instances. Spot are not, right? So you run this reserved instances on a daily, weekly, or monthly basis. After you purchase your reserved instances, they are available to launch during the time windows that you specify, right? And can be launched via the AWS Console Management Console, CLI, tools for Windows PowerShell, and the Run Schedule Instances function. Okay, This is something for more than anything else, right? Developers. But this is the function that runs when you schedule an instance, right? Behind the scene. Okay. So a scheduled instance is a reserved instance, but that is scheduled, right? It's like a type of reserved instance, like convertible. Convertible is another type. Schedule is another type, right? Use cases of scheduled instances. A bank performs value at risk calculation every week afternoon, right? They work every afternoon throughout the week. A phone company does a multi-day bill calculation run at the start of each month. You know, it's multi-day, like 3 or 4 days, right? At the start of each month, you know, the schedule is a schedule. A trucking company optimizes routes and shipments on Monday, Wednesday, and Friday mornings, okay? An animation studio performs a detailed compute-intensive 3D rendering every night. You see, like this keyword here, every, you know, every on Monday, Wednesday, Friday morning, you know, like every Monday, Friday, Wednesday, and Friday morning, every start of the month, you know, that's when you schedule an instance. They are reserved, but they're scheduled as well for a particular time, either daily or weekly or monthly, right? Using EC2's different pricing models. So this chart illustrates a very basic way to use reserved instances and on-demand instances together to accommodate, because guys, by the way, you can have both together, okay? Working together in the same infrastructure. So you accommodate fluctuations in demand over time. In this example, multiple reserved instances were purchased and they are running, right? However, as the day goes on and demand increases, the need for more instances increases as well. This customer supplements their capacity with on-demand instances, which can be shut down when they are not needed later in the evening. You see, they combine.
Exactly. Yep.
They combine reserved instances with on-demand, right? Because they have both unpredictable traffic and demand. All right. So this is for reserve. You see here, how it's constant here, and on demand. You see, you know, specific times of the year, it goes up and then it goes down, and you can shut it down. Right. Right. Remember, when this happens, if you have an elastic load balancer, like we spoke about last class, and your elastic load balancer, you know, the traffic goes up like 50% and your elastic load balancer is not ready for that traffic, then you should contact AWS to pre-warm your elastic load balancer with more nodes, right? To be able to cope with that demand that's going to happen. Right. So you can have the combination of on-demand, reserve, and spot, right? So it's like I said before, it depends on your business. You may or may not need this, right? So in this chart, the customer takes a more complex approach that attempts to use all three price models. In this case, some of the supplemental instances come first as on-demand instances, but further needs are addressed with spot instances. This allows the customer to save money by using spot instances over on-demand instances. However, this practice exposes the customer to unexpected instance termination, right? Remember that spot, you may lose them, right? So if that happens, you will lose those instances if they are all bid, like I said before. This situation could lead to lost data or insufficient capacity for your customers, which means that a model like this should only be implemented in circumstances when the sudden termination of instances is acceptable and is handled appropriately. It's like I said before, you know, if you have everything in place to be able to cope with the termination of a spot instance, you don't have to worry. Okay, you don't have to worry. So you can use these guys based on your needs, right? Your business needs. But if losing data might be a problem for you, don't use spot instances. Okay, or if you use them, be ready to save your data before you lose it. Okay, so we can have the combination of reserved instances and on-demand, and you can have the combination of reserved instances, on-demand, and spot. Remember that each of them has a different use case, right? Reserved instances is for predictable patterns. On-demand is for unpredictable, and spot is for instances that can be interrupted at any time, right? It's for spare capacity. You need more capacity, large capacity. You can use that, okay? And termination is imminent once they notify you, okay? So you have to do something. You can keep them by paying more, outbidding the bidder, the last bidder, or the highest bidder, or just saving, you know, all your data, back up all your data, and just let them go. Okay. The blended approach. Okay. So what it means is that you choose the instance type that matches requirements. You start with memory requirements and architecture type, 32-bit or 64-bit, and then you choose the closest number of virtual cores required. You know that when you choose an instance, one of the things that you have to consider is the cores. No, this is a computer, right? You know, computers, usually they have an 8-core, 9-core, 16-core, you know. So scaling across availability zones, right? It's this part here, right? In smaller increments, it gives you more granularity for deploying to multiple AZs, right? So the more availability zones you have, the more flexible and highly available your application will be. So we spoke about that before. We said that we have to have minimum 2 availability zones, right? But something that you have to bear in mind is cost. The more availability zones you have, the more high available you're going to be, right? But the more money you will have to pay. So it's something that you have to balance out. Okay, like I said before, you sit with the person. Let's see your application. How highly available do you need to be, right? You have to bear in mind that this is going to cost you more, right? But let's look at a way to compensate this, right? This is going to cost you more. Let's look for it for probably a lower capacity EC2 instance. Less reserved instances if your traffic is predictable throughout the year, right? Or let's have some spot instances, which is the cheapest of all the instances, right? Even though we reserve instances, you save money, the cheapest of all is spot instances. Maybe you want to save money. Let's go with spot instances. But something that you have to consider is that you may lose all your instances. Termination is possible. Okay? You want to go with that? Let's go with that. Let's go with the most cost-effective approach. Something that they like to ask you in the test is cost-effective, best. Okay? You may have 4 solutions that are good. They are effective, but you have to look for the one that says best, right? So that's a very tricky question. When you read all the situations, all the solutions, and wow, this is possible, this is good, but which one is the best? Okay, which one is the most cost-effective one? So that's very important. You start with on-demand instances and then assess usage for reserved instances. We start with the lowest, right? On-demand, right? You know, just in case there's just some spiky traffic, we get it, right? And then based on the usage throughout this period, then we can go for reserved instances. So it's like when you create a user, you apply the principle of the least privilege, right? the least privilege. You don't give a user any privileges, right? Only what they need for the job. Same thing with this. We start from below, for low, right? With on demand. Let's work with this. Let's see how it goes, right? If you need something, more steady, like more constant, then we go with reserved instances. Okay? Let's just watch the traffic. Let's watch it throughout the year and let's see how it goes. Remember, when AWS works with a company, they don't just sell them the instances and then leave them alone, right? They're still working with AWS all the time. Remember, you're going to work with them. You're using their platform. Then they're going to leave you alone, right? And they want to continue making money. And number one principle of the 14 principles of leadership of AWS, of Amazon as a company, Amazon, is business obsession, right? They are business obsessed. So not business, I'm sorry, customer obsession. They're obsessed with the customers. They will not leave the customers alone, never, right? Because they know that, benefiting the customer is what really keeps their business running, right? Part 3, dedicated instances and dedicated hosts, okay? Some people, sometimes they ask, Professor, what's the difference between a dedicated instance and a dedicated host? And I have the question for you guys right now. Can you give me that answer?
So to me, a dedicated host, it's like you own that equipment without you having physical access to the server. You own that whole, you don't have any other customer, anyone else, just you are in that dedicated equipment. You don't have any partitions that belong to other companies.
Mm-hmm.
You are the owner of that host. Well, not the owner. You're not owning, you're renting, but you basically are the only tenant on that host.
Okay. It's a single tenancy. Good.
Single tenancy.
Right. So if you want to compare dedicated instances with dedicated hosts, let's see it this way. A dedicated host is the hotel and a dedicated instance is a room of the hotel. Okay. An instance is an instance, right? A dedicated host is the one that has all the instances, right? It's like the hotel has all the rooms. The host has all the instances and it's dedicated. This is usually used by the government. The government have dedicated instances, dedicated hosts, because that's only for them. It's a single tenancy. What we've seen so far is shared tenancy, right? It's the one that can be used for other people. Your company can use different tenancies, but a dedicated instance is for a particular department or for a particular enterprise or a particular business. No one else can use that, right? It's not shared. So this is a side-by-side comparison of dedicated instances with dedicated hosts. For example, they both have dedicated physical servers, right? They have physical servers that are dedicated. Per instance billing, the subject to a $2 per region fee. Dedicated instance has that. Dedicated host doesn't have that. Okay. Per host billing, of course, a dedicated instance is an instance, is not a host. So that doesn't apply to dedicated instances, but it does apply to dedicated hosts. Visibility of the socket, the cores, the host ID. When you have an instance, you cannot see that, right? But when you have a host, then you can see it. You can see the sockets, the cores, the host ID, and all that. Affinity between a host and an instance, of course, you cannot see that with an instance because an instance is an instance. But a host, you can see you have a wider view of all the instances. So you see the affinity between all those instances and the host. Right? Targeted instance placement, of course, the dedicated instance is an instance, right? And we're talking about the placement of that instance. You can only have that when you have a host, and then you can place instances in the host. Automatic instance placement, this dedicated instance can be automatically placed, right? And the same with the host. And then you can add capacity using an allocation request. Here, you don't have that, but in the host, you can have that. Okay, so we can go there, see. It's obvious they have difference in price. Okay. You see, that's what we see before. Use the host to have more visibility into the physical host of the by your own license. Okay. So you should also try dedicated host if your application requires minimal latency between instances. Use dedicated instance if you're only concerned with the compliance with regulations. In terms of pricing, if you're able to maximize the number of instances on a dedicated host, you will pay less versus dedicated instances. The percentage savings depends on your scale due to the 2-hour flat fee. In our opinion, it's not worth the headache unless by your own license or internet network performance is a concern. Dedicated instances is the way to go due to the flexibility of launching instances, of course. When it comes to flexibility, it's a dedicated instance is just like an instance, but it's dedicated. So when you come here, oh, by the way, you can do this. You can do this. I didn't tell you before. I hadn't told you before.
How did you do that?
Okay, you can come here, grab this,
That's awesome.
grab here, put it here.
I love it.
So whenever you have to go to EC2 instance, you just come here and that's it. S3, you come here. Yeah, I saw that also Gabriel has it. So if you create an instance, right? Tendency, you see? Right? So we've been choosing this one, but you can choose dedicated, run a dedicated instance or a dedicated host. So this instance will be launched on a dedicated host. Okay. It's like I said, instance is like a room in a hotel and the host is a hotel. Okay. Of course, this is going to cost you more, guys. It's dedicated, right?
So how do you designate a dedicated host?
Okay. You have to have a host for that.
I know. Where do you go for that?
Okay. Launch instance to a host group. You have to have the host here. Use auto placement.
That's my question. How do you get that? How do you get the host ID?
Okay, the host is for AWS. The host is in the hypervisor of the AWS.
So let's say that I want to run a dedicated host. Where do I go?
I don't think you have to rent a dedicated host. You select this one, and AWS will choose the host for you. It's because here there's no, there's no host resource group. Okay, let me see. You have to have your license. Okay. Host resource groups in AWS, create a host resource group. Console here. Create a license configuration. This is a way, Maria.
It's in the menu. I put it on the chat. There is something in the EC2 dashboard that says dedicated host. Is that where you went?
Wait. So I click here.
No, go back. Can you cancel this? It's on the left side of the menu. It's according to the document. Dedicated host. There you go.
It says new.
It's new. Yeah, it's something new. Interesting.
I didn't know about that. Something new. So that's why we have to keep, updated with the console. They adding new things. For example, they add a few features for security groups, Elastic IP. They constantly adding things because they're modifying the console.
I knew they will automate this.
So
what is it asking?
dedicated host allows you to provision EC2 instances on physical servers fully dedicated for your use.
Mm-hmm.
Okay, instance type. You select instance type. Oh, it's like creating an instance, like creating a configuration. So let's say my new host, instance family. Let's say choose an A1. Okay. Support multiple instance types. Enable. Okay. Availability zone. I want to hear. I can only choose one. Okay, I want to hear. Instance auto placement, enable.
What does that mean?
When you create an instance, it auto places the instance there automatically. So disabling auto placement will reserve the dedicated host for targeted launch requests. Enabling auto placement will allow untargeted, no host ID specified launch request to succeed without specifying the host ID. Host recovery. I don't know. I'm gonna delete this immediately. Okay, this cost.
Yeah, you don't want. Yeah, this one is the one that charges.
Yeah, and I want a quantity of host. I only want one. Okay, and then let me allocate this. Let me see if it works this way. The number of dedicated hosts you requested would bring your total up to one. First paragraph. This exceeds your current limit of 0. So I am within the free tier. Oh, let me see. If I choose C5. Oh, I guess this is a soft, this is a soft limit. If you recently released dedicated host, it may take some time for them to stop counting towards your limit. Try allocating your host again after a few minutes. Please visit.
So does the free tier doesn't allow you this? Is that why?
Probably as a new account, I can have that. This probably is a soft limit. Let me see. Host limits for new accounts. AWS. So probably my limit is 0 for a new account. Or because I'm within the free tier. To be honest, I never had to try.
I'm trying to get to
I
see.
never tried this before. But it's a learning experience. That's good. Well, obviously, this is telling me that I cannot create a host. I can't because I have a zero amount. I requested 1. It will bring your total up to 1 for the specified group of instances. This exceeds your limit. So my limit is 0.
Nothing is 0.
If you recently released dedicated host, if I terminated a dedicated host recently, then I have to wait until that it's available. I haven't done that, so my limit is 0. Okay. You see, I will have to contact AWS to get an adjustment in my limit. Request to increase the service limit of AWS resources. Limit type, it's EC2 instances. And the region is North Virginia. That's the one that I was trying to get the host from. And I think I was trying instance type. Let's see. Oh, standards. New limit value, maybe I need 2 or 1. Let's ask for 1. And then I just put here, I want to increase my limit for dedicated host as my company requires. And then English, I want to be contacted via email support center, or they're going to call me. Okay. And I'm not going to submit that. Okay. So you can try that too, guys, but I believe that you're going to have the same result. Okay. So it's a soft limit, and then I can ask for, but I'm not sure if for the new account it's a soft or hard limit. I'm not sure. It's a new account, and if for 12 months only, probably when it turns into a paid account, then I can have that benefit. So dedicated instances, single customer tenancy or on compute hardware. Okay. Physically isolated at the host hardware level. That is right. From other instances that are not dedicated instances, it is only for you, right? It has nothing to do with the other ones that are not dedicated. And it's also isolated from the instances that belong to other AWS accounts. Useful for workloads with unique compliance requirements and may not be needed unless physical isolation is required. So if there's no physical isolation, you don't need these guys. Right? So a dedicated host is a physical EC2 server with instance capacity fully dedicated for your use, right? So an instance is just a computer. A host is a platform. It's a server where you can put different computers. Okay, that is the difference. Now that's for you. We have to request a host, like we said before. If you reach your limit, you have to increase that limit and create a host. Once you have the limit restored, then you can create a host, and on that host, you can launch your EC2 instance, right? So dedicated host can help you use your existing server-bound licenses, bring your own license, and meet compliance and regulatory requirements. Right? AWS Trusted Advisor. We know this guy already, right? We know this guy. Now, AWS provides best practices, Trusted Advisor, in cost optimization, which is the pillar that we're talking about. This is the guy that helps you save money, right? Security, right? Fault tolerance, right? Performance improvement, and service checks, right? There's something here that we don't have here, and I will add it, the limits, okay? Whatever limits you have in your account, this is the guy that will give you recommendations, right? So I think this is one of the instances that Trusted Advisor will tell me you need a host, or your limit, you have reached the limit of your goals, of your hosts. Okay. So the best practices for AWS Trusted Advisor to all customers: service limits. This is for all customers, because you can have the basic Trusted Advisor, which is for all customers, and the full Trusted Advisor, which is only for the full. It's only for the business and the enterprise plans, right? Security groups specify ports unrestricted, IAMUs, MFA on root account, Amazon S3 bucket permissions, Amazon EBS public snapshots, and Amazon RDS public snapshots. So it will give you, a recommendation of all this, right? And this is for all customers, all plans, basic, developer, business, and enterprise. All right, guys, I think it's time for the break. It's 2:28. I see you back at 2:38. Hey guys, we're back. So here, these are some of the features and functionality of Trusted Advisor. This is within the console, okay? Sorry. So within the console, you have notifications from Trusted Advisor. They help you to stay up to date with your AWS resource deployment. And you're gonna be notified by weekly email when you opt in for the service, and it is free, okay? So you can use AWS Identity and Access Management, right here, IAM, to control access to specific checks and check categories, okay? You can retrieve and refresh Trusted Advisor results programmatically by using the AWS Support API. So from the console and the SDK, you can, get all the results from AWS, Trusted Advisor. The action links, they are hyperlinks on items within a Trusted Advisor report. Using action links takes you directly to the console where you can take action on the Trusted Advisor recommendation, okay? So when they send you the recommendations, there are gonna be links inside, and then you can click on that, and it will take you to the Trusted Advisor recommendations. Now, the recent changes, you can track recent changes of a check status on the console dashboard, and the most recent changes appear at the top of the list to bring them to your attention, right? So you're gonna have this symbol here, like this is a warning, like a triangle with a exclamation mark in the middle that says that, there's a warning there, right? And that something it's not wrong, but you might take a look at it because something is not completely working properly, right? So you may have this guy that is giving you like an alert, something has to be worked on, right? And you can also have the green, which is when you have everything right here, the green check mark, this one, that's telling you that everything is okay, right? So the exclude items right here, it allows you to customize the Trusted Advisor report. And you can exclude items from the check result if they're not relevant. Okay, when it does a check, health check, like it says here, service health checks, service checks, you can exclude some items that they're not relevant to you, and then they will not appear in the report. And then you can refresh individual checks or refresh all the checks at once by choosing the refresh all button here in the summary dashboard. A check is eligible for refresh every 5 minutes after it was last refreshed. Okay. So AWS Trusted Advisor dashboard, this is what you see in your console. If I come here, my console is here. So I can type it, Trusted Advisor. See? So this is the refresh button here. This will check all the checks. So here, all the checks, they're refreshing here. Or you can refresh them individually here. Okay, one by one if you want to. And remember, they are only eligible to be refreshed every 5 minutes. So when this is finished, I have to wait 5 minutes to refresh them again. And it tells me here how long ago it was refreshed, a few seconds ago. All right. So obviously I don't have any warnings in my accounts because I don't have any services running, right? So everything is okay, right? I'm not saving any money, right? Oh, what is this? Security. Oh, security groups, some ports are restricted. Okay, let me check this. Access ports to 2021 1433 unrestricted yellow. Okay. Really? Let me see. Three entries. Let me see this one. Or 80, 80, and 22. 80. Did I put any range or anything? Port range. Oh, see here? That is not good. Let me remove this guy here. And this guy too. What else? Two entries here. Let me see this. Oh, 80 and 22. And this entry, three entries is 80 and 22. Oh, what did I click on? Okay. All right, so trusted advisor. Trusted advisor. So if I refresh this, I have to wait 5 minutes. Okay, not a problem. I come back and refresh this. You see the security groups is telling me here, this is a warning. This is that I have here for 5432. 5432. The other ones are fine. This is the one that I have to, and then it gives me the link here. So I can come here and fix it. But I think that I fixed it already. One entry. Oh, right here. Oh, I have opened this Postgres. Okay, let me delete this. I don't need this. So now if I come back and refresh it after 5 minutes, then I can, it says checks have been refreshed. Okay, so I can come here after 5 minutes. It was 3 minutes ago, so I have to wait maybe a little bit more. And then everything should be good because everything is green, so everything is fine. And of course, the warnings will bring it to the top of the list, so it gets your attention, right? So I have some public here, probably some public buckets here. You know, open access, they're public, right? And it says 2 of the 12 buckets have permission properties that grant global access. So if I come here to S3 and I check here, there should be 2 that are public, these 2, okay? But these are my websites. But it doesn't give me like a red thing, you know, it's telling me it's open. So be careful with that, it's open, right? How many minutes ago? 5 minutes ago. So let's say in any minutes, it should be ready to be refreshed. Okay. If I refresh the page, sometimes it takes a little bit longer. Okay, I come back later. Okay, so we see this here. We saw already in full advisor, trusted advisor, what happens. Okay, so we can continue here. So case study, Hungama, using AWS Trusted Advisor helped us save 33% on our monthly bill. And we'll continue to use it to optimize our infrastructure and costs on AWS, right? So Hungama has used AWS for server and storage management since 2008. So AWS came in business in 2006. So they are one of the pioneers with AWS, because 2 years later, after they started the business, I think it's one of the first companies to come with AWS. All right, so they deliver content to customers in 47 countries across mobile, internet, and internet protocol television, IPTV services. The company uses Amazon S3 to host more than 60 terabytes of content. And Amazon EC2, you see, these guys are not using Lambda, okay? Because not everybody wants to go serverless, simple. Or probably they don't know the benefits of serverless applications. And RDS for server and storage management. As the company grew rapidly, more departments used AWS for development, causing an increase in monthly costs. Okay. So, Hongama, this is kind of contradictory, right? Because what we know so far is that AWS saves you money. It doesn't make you spend more, right? And when you read this, is wow, what is this? Why should I go to AWS? As the company grew rapidly, more departments used AWS, and the cost increased, right? Yeah, but we have to see how efficiently these people were using the services, right? Maybe they were over provisioned. Maybe they were using services that they were not needed, or maybe they were running instances that they were not using. So they had to use Trusted Advisor, right? So when they used Trusted Advisor, they saved 33% of the monthly cost. So how did they do that? They used Trusted Advisor cost optimizing checks. Here are a few things they did. The low utilization Amazon EC2 instances check revealed over-provisioned instances sizes, and instances spun up for special projects were not terminated after completion. Okay, that's illogical, right? If you're not using them, terminate them, right? In response, the audit team used this information to right-size their instances. They also categorized production and development servers and automated the process of shutting down development servers during non-business hours. Remember when we studied cost optimization? With Trusted Advisor, that one of the points that we saw is right size, choosing the right size. Okay, so they chose the right size for their instances, and they automated the process during business hours. So they scheduled their servers to be running, let's say from 9 to 5, and then they stopped them after 5 until 9 the other day, right? So on Hongama's reserved instances, Hongama reduced monthly costs by 33% by using Trusted Advisor. How did that? Okay. The reserved instance optimization check identify additional opportunities for optimization of the reserved instances they had purchased. Even they purchased the reserved instances, they still could optimize that with Trusted Advisor. In response, Hongama changed how they reserve their instances and based reservations on their specific usage patterns of their different instances categories: development, production, test, etc. Right? Hongama snapshots. Hongama reduced monthly cost by 33% by using Trusted Advisor. So what did they do? The underutilized Amazon EBS volume check identify a number of unused or underutilized EBS volumes that were often left over from previous test projects. Okay, so that happens when you terminate your instance, but you keep the EBS volume, right? You have that option to keep it when you terminate the instance. So you don't have any running instance, but you still have the volume, so you're going to be charged for that, right? And Trusted Advisor would tell you that there is an EBS volume that is not being utilized. So you have to delete it, right? In response, the audit team created snapshots of many of the underlying EBS volumes, which they store on Amazon S3, and then deleted the volumes, right? But don't delete them before taking a snapshot, right? Snapshot is a backup of your information, right? It's like a picture, like an image in time of that particular EBS volume, right? So this resulted in a reduction of over 90% on the number of snapshots generated weekly, okay? Of course, you have a lot of EBS volumes, and you have a lot of, a lot of automated snapshots. You have like a lot of the snapshots generated weekly. Okay, if you delete the EBS volumes and after taking a snapshot, you're not going to have that much or that many of snapshots weekly. Okay, now caching. Serving content with caching. The more you can upload, the less infrastructure you need to maintain, scale, and pay for. Guys, as you know, the Content Delivery Network, or CDN, refers to CloudFront. You know that already, okay? So CloudFront is a content delivery web service. It gives developers and businesses a way to distribute content to end users with low latency using cache edge locations. Okay, so it can transfer data real quick with no minimum usage commitment. Depending on your application type, it might make better sense to distribute your static or dynamic content through CloudFront instead of scaling out your infrastructure. Okay, so let's take a look at the response time versus service load if you don't use a content delivery network. Without a CDN, the response time goes up and the load on the origin is much higher. Okay, so when only static content is offloaded by using a content delivery network like Amazon CloudFront, the response time and server load is reduced by half. And that's very, very important. By half, that's super important. So if both static and dynamic content are delivered through Amazon CloudFront, you have larger savings in terms of server response time and an even larger amount of savings on the server load. This scenario here, in this chart, it means that you can have smaller and fewer instances at the origin if that work is offloaded to Amazon CloudFront. Okay, so here you don't have any content delivery network, no Amazon upfront here, right? So you look at the response time; it's very, very, very high, right? And the server load is high too. But when you have CloudFront with static content, it is reduced by half here. The server load, see, it's almost a half here, and response time is reduced drastically as well. But when you have both static and dynamic content served by CloudFront, the response time is even lower, and so is the server's load, right? So this guy, even though this solution is more expensive than this one, in the long run, you're gonna save more money with this guy, okay? Because, when you have better user experience, you have more people, right? More people coming to your website, right? And you're offloading the server more, right? The server load is less, right? When you have this guy, because you start, caching all your information in the edge location, right? So you offload the popular traffic to Amazon CloudFront and Amazon S3. S3 as the origin of the CloudFront delivery, right? And then you introduce caching. You know that already, guys. This guy it works with his child, I would say that edge locations are the children of CloudFront. Right? They work together to make the user experience more excellent, right? So cache everything, okay? Databases can be cached to Amazon Elastic Cache. Database types include NoSQL instances like MongoDB or Amazon DynamoDB, and also include relational database servers, right? So, guys, do you remember the service? Sometimes that my mouth is very dry. That's why sometimes my words. Do you remember the service that is used for caching in Amazon DynamoDB?
Elastic Cache?
Nope.
It's a Dynamo
Accelerator.
accelerator.
DynamoDB Accelerator, also
Uh-huh.
known as DAX. Okay, that's the one that is used for caching, for Elastic Caches for RDS. Okay. So we have
It's going to be from MongoDB.
huh?
The same, MongoDB, it's going to be the same like for the DynamoDB.
Yes, because that MongoDB is a NoSQL database, and DynamoDB is a third-party database. Remember, it's not in the 6 engines that RDS supports. Right? It's a NoSQL one. Have you ever seen have you guys seen how MongoDB works?
Isn't? Nope.
No?
Nope.
Well, I can tell you the MongoDB works with JSON. Okay, let me show you.
Is it non-relational database?
That is correct. It's a schema-less database.
I don't like.
No relational. There's no schema like
Is it like DynamoDB?
similar to DynamoDB.
Okay.
So MongoDB schema, for example, schema example. By the way, it's super popular. Okay. Let me see if I can log in my account. I have an account with Atlas. See if I can see here. There you go. This is how MongoDB has its own data, right? So I can have one table here that has this. I don't have any more tables. I only have the users table. You see? Okay. But it's different from the other relational databases. This one doesn't have a schema. It's a very strange thing. It's not like the other ones that have a schema structure. This is unstructured. Like DynamoDB is not structured database. All right. So we have here instances that work with this guy, Okay. So you can use /cache for these guys too, for Amazon DB as well. I don't know why they put here /cache for DynamoDB. Kind of confusing. So my understanding is /cache is for
Yeah, you're right. Maybe it's just a general term, the fact that you can cache elastically, but DynamoDB uses DAX.
This is the guy that I understand is for DynamoDB. You see, there is in memory caching.
No, you're correct.
So AWS is offering in-memory stores, allowing you to cache read requests to DynamoDB. Elasticache is a managed service provided to engines, Memcache and Redis. DynamoDB streams is when you make changes to DynamoDB. Okay, DynamoDB versus Elasticache. They're two different things. Two different things. DynamoDB, Elasticache. Okay, so Elasticache is for RDS, right? Maybe they're trying to show you another thing here, okay? But use cache for everything. Cache is very important, okay? So DynamoDB Accelerator for Amazon DynamoDB, and caching for Amazon RDS and MongoDB. And what is Elasticache? It's an in-memory cache solution, in-memory storage. It means that it would go away after a certain time, right? It has a time to live. So we have spoken about this guy numberless times, right? The total cost of ownership, TCO. I believe for those who took the exam for the cloud practitioner, do you see this guy in the exam?
Oh yeah, many times.
Many times? How about you?
Oh yeah.
Anand, are you there?
Yeah, he responded. He said all the time.
Yes, all the times.
Wow. So use a detailed set of reports that can be used in executive presentations, modify assumptions that best meet your business needs. So here you get a description of your infrastructure in 4 steps, right? Or enter detailed configurations. You get an instant summary report, and then you'll download the report, including detailed cost breakdowns, right? So we can use the TCO by reducing the need to invest in large capital expenditures. We provide a pay-as-you-go model that empowers you to invest in the capacity you need and use it only when the business requires it. So the TCO allows you to estimate the cost savings when using AWS and provide a detailed set of reports that can be used in executive presentation, like you say here, summary report, all that, right? So for more, the link for this guy is this one. All right, if you want to know more about that guy. Okay, I sent it to Maria. Oh, to everybody. Okay, let me see if it works.
Taking a long time to respond.
Yeah.
My internet, what the heck is going on?
Yeah, it took a while for me too.
Oh,
Yeah. I think it's probably a site issue. Okay, so the simple monthly calculator. Remember, this guy, I think it's June 30th. It will no longer exist, right? I think it's going to be AWS calculator after that. So here, it's going to tell me now. Yes, thank you for continuous feedback for your AWS pricing calculator. It's going to be called AWS pricing calculator after June 30th. To ensure the features requested from customers are available in the AWS pricing calculator, the simple monthly calculator's deprecation date has been delayed from June 30th, 2020 until further notice. So it's not the 30 anymore. These people are constantly changing everything. We will.
What did he say? I was
Yeah.
looking at something else. What does it say?
Previously, the simple monthly calculator was going to disappear on June 30th, right? And it's going to be called AWS pricing calculator. But now the date has been delayed until further notice. Okay? So we will continue to add services and features to the AWS pricing calculator. During this time, please continue to access the AWS pricing calculator and provide feedback using the contact us button below. All right, so you can use a simple monthly calculator or launch the AWS pricing calculator. All right, so we're still using the simple monthly calculator, but until further notice, we still don't know what's going to happen. It was scheduled to be, terminated on June 30th, and this guy was going to be the only one doing the job. But now we have both. Right? Now we have both. For now. Okay? All right. So improve your architecture. Your team perform a security, reliability, and performance assessment and put in every option they thought would increase performance. Your cost explorer indicates that your forecast is higher than your budget. Review the diagram and ask questions to identify where improvements can be made to improve the cost optimization of the system. Recommend ways to redesign the solution in accordance with the well-architected cost optimization pillar. This is the guy. So let me copy and paste the questions that you should ask yourselves, guys. Let me see. Let me copy the questions first for you guys to see. Why is not copying this? Guys, do you have access to Slack now?
Yep.
Okay. I'm going to paste it on the main chat, Solutions Architect chat. So those are the questions that you guys should consider when trying to, analyze this graphic. So take a look at the questions. So the first question, are there unbalanced instance sizes?
Hold on, I'm trying to look at this side by side. Make this bigger.
Is there any instance that is not balanced?
At the bottom. Let me see. That's the database. What is that symbol?
Okay, so Chris is saying the web servers, rather web app servers. Okay. Okay. Are the web servers balanced?
No, one is an extra large and the other one is a large.
No, when I said balance is elastic load balancer.
Oh, the elastic load balancer.
But what you're saying, Christopher, makes sense, right? Because we have in one availability zone, we have C4.x large, and in the other one, you have M4.large, right? Well, actually, the databases, you have one that is a standby, right? You don't need elastic load balancer for that one, because that one is not doing anything. It's just waiting, you know? Obviously, this architecture is multi-AZ, right? So we're using multi-AZ deployment, and the database in the right-hand side, the availability zone that is at the right.
Just waiting for.
Yeah, it's a standby database. That one is. So, but both.
I need the symbols again.
Yeah, they both have elastic cache, right? Just in case the first one goes down, it will fail over to the one in the second availability zone, and that one will still have elastic cache. So this one will be standby. Do you see my cursor, guys? My cursor? You guys see my cursor? Okay, good. So this one is standby. This one will be promoted to a master database, right? So this one, C4, X large, and this one M4 large, kind of unbalanced here, right? One moment. So if I trying to be highly available, why would I have a type here, an instance type here that is different from this one? Why would I have that? What sense does it make? If I'm going to fail over to this availability zone, if this one goes down, does it make sense? Look at this type and then this type. Right? So they're balanced because they have an elastic load balancer, but when it comes to balancing, like they have the same type, they're not. Right? They don't have the same instance type. Right? Am I saving money here?
No.
Okay. Right? So the M,
Sorry.
so we have the C's here, and then we have the M here, right? And then we have, I think that this is more clearly seen when you create an instance. Okay, let me create an instance here. I come here and select the type. So we start having this here. So we have a name here, right? So the one that we have is M4 large. This one here, right? And the other one is a C4 extra large. C4 extra right here. You see? So the general purpose one, it's cheaper than the compute optimized ones. Okay, so obviously we are going, you know, from a general purpose one to a compute optimized one. This is not balanced at all. Okay, so we're not going from one type to another type that is, you know, the same type. One instance to the other instance that is the same type. Even when you go up or you go down, I mean, that doesn't make sense. If you go up, you're not saving money, just in case you need it, right? But if this is for the purpose of being highly available, you're not saving money. And if you go down, you may be on the provision. So what's the point, right? If this is going well, why should I have a smaller one or a biggest one here? I should have the same, right? So another question is, why should you use a C4 for an EC2 instance for a web server? Well, that depends on the business, right? The other question is, why run large web or application servers behind small reverse proxies? So what is a reverse proxy? Reverse proxy, as the name suggests, does the opposite of what a forward proxy can do. It takes requests from the user and forwards them to the host web server acting as a load balancer. To summarize, the forward proxy hides the client, whereas the reverse proxy hides the server. Okay. So why would you have this instead of a load balancer? Good, Chris. That's true. The M stands memory and the C CPU. So M4 is for compute optimized, for applications that need a lot of memory, and C is for computer applications that need a lot of CPU. Okay. So it doesn't make sense, right? Why would you use one type and then the other type on the other side? If you're the same architecture, it's weird. That's right. It's weird, but this is intentionally created for you guys to analyze it. That doesn't make sense, right? So why have do-it-yourself databases over RDS? That's another question. And what is do-it-yourself? What is do-it-yourself? Guys, are you here?
Yes?
I am here.
What is do-it-yourself versus RDS?
Still trying to figure out the.
I mean, I don't want to say something wrong, but maybe do it manually or something like that. I don't understand.
I don't understand the darn symbols.
What symbols?
The symbols for the apps. That's what I've been trying to do for the last few minutes.
Okay, this is instances. The last two load
Both
balance.
of them are some, but what about the one in the center? What is this
That's auto
circle with the cross on it and 4 arrows? And I don't know what that means.
Auto scaling,
Auto scaling. And the one down below?
route table.
A routing table. Okay.
And this is elastic load balancer.
That one I remember, yeah.
Elastic Cache, database, EBS. EBS.
Oh, that's EBS. Okay.
Volume. Amazon RDS, CloudTrail, CloudWatch.
Yeah, this one they tell you, but the
Yeah.
ones in the middle.
Yeah, that's EBS. No, do yourself is not NoSQL. No, do yourself is when you have to install the database. For example, when you use EC2 instance, and on top of that, you put a database, you have to install the software.
So when you do Microsoft,
Self-managed, that's right.
yeah, okay.
Right? RDS, you don't have, it's a managed service. Okay? So the question is, what would you use do yourself instead of RDS? I think that the answer is obvious, right? So the other question is, why use Amazon Elastic Cache? What purpose does it serve?
Easy access to data that it's accessible often.
Reduce for performance.
So yeah, exactly, Chris. Reduces latency.
Reduce latency, that's right, because it caches the information in the Elastic Cache.
Mhm.
It's not in memory store, right? Yeah, reduce time to access. That's right. What do you say, Oliver?
I say the performance.
The what?
Better performance.
Yes, that's right.
But
Okay.
why you use two? The one is, why do you use two cache?
Oh, because this one is standby. It needs a cache too. If this one goes down, this one will come into place, right? It needs
Okay.
that one needs cache. This one is for this one, and this.
Okay.
Okay, Did you talk about on the apps, web app server area? One has a C4, the other one has an M4. Shouldn't they be both the same?
We spoke about that. Yes.
Yeah, I know. I was looking into the symbol. Sorry.
Yeah. It doesn't make sense that way.
It should be the same, right?
It should be the same, of course. Yes.
Now, what would be more sense? If we're talking about a web app server, are we talking about optimizing for memory, optimizing for CPU?
Yeah.
I would say CPU, but
When you see that starts with C, that's CPU, M is memory. So it depends, right? If your application needs high memory, then we use this one. If you use a lot of CPU, then you need this one. But they have to be the same because it's the same architecture. And this is for failover. This is multi-AZ.
what is a reverse proxy?
A reverse proxy is a proxy that hides the server. What it does, instead of sending the traffic forward, it transits backwards. So as the name suggests, it does the opposite what a forward proxy can do. It takes requests from the user and forwards it then to the host web server, acting as a load balancer. To summarize, the forward proxy hides the clients, whereas reverse proxy hides the server. So in other words, you're using this instead of a load balancer because it sends the traffic to the server instead of to the client.
Wouldn't be cheaper to have an elastic load balancer than having another instance?
Yeah. It's more highly available as well. Yes, it makes sense, Chris, separate the web server from the app servers. That's right. That is correct. Yeah, a proxy server, what it does is when it comes to traffic from the web server, let's say you're going to send an email, right? It comes to the proxy server and then it goes out. Sometimes companies have a filter. For example, in Cuba, when you are in a workplace, they don't want you to talk about the revolution and talk about evil about the government. So they put some proxy server with some filters that whenever you send an email saying this country is a piece of, whatever we're going to say, then the email would not go out. It will stay there or be eliminated. Okay. So there's a filter. So this one does the opposite. The reverse proxy, the traffic comes in, and what it does is sends the traffic to the web server. It's the opposite. It's a reverse proxy. It works as a load balancer, but it's more overhead because it's an instance. Right? It's an instance. You don't need that. You need an elastic load balancer. Right? But this is intentionally created, guys, for you to analyze it and realize that there's some stuff here that doesn't make sense.
Did you talk about the Bastion server?
This one is fine. This one is fine. We haven't talked about it. Nobody mentioned it in the chat. This one is used, but if you have a proxy, a server, a proxy, you don't need the Bastion. It's either one or the other, right? But you don't need the reverse proxy either because you have elastic load balancer, right? So
the Bastion server basically serves like a policeman.
That's right. It's like a guard.
Why have that there and not use a more dynamic application or environment to do that? Can you use like a firewall in there or some sort of a
firewall is for a computer, for a server, and NACL is for the subnet, but you still need something to protect things inside the subnet, right? The traffic comes to the subnet, but if you have a server here, you need a security group, right? Now,
you use a web server as a Bastion in that instance?
A web server is not a Bastion. A web server is a server. Now, a Bastion is a special web server. Two different things. So usually, we put a Bastion when there's nothing in the subnet. There's nothing here. There's no web server here. The web server is down here. So you put a Bastion here, which is in the public subnet, and then it allows the traffic into the servers. Okay? It's similar to a NAT gateway, similar, but the NAT gateway is from the traffic in out. You see, a bastion is for the traffic coming in, and NAT gateway is for the traffic going out. Do you understand?
Yes, I understand. I still question that. If you have
I
a
don't
web
understand the
server-
Bastion server. Why we will use the Bastion server?
Okay.
Thank you, Rivera. Yes.
Obviously, it's for more security, okay? But I want to give you a better explanation. Okay, let me ask you a question.
By the way, this is also a lot of questions on this.
Bastion host is a special purpose computer or server on a network specially designed and configured to withstand attacks. You know, it protects the whatever is inside that subnet or going to the other subnets. The computer generally hosts a single application, for example, a proxy server, and all other services are removed or limited to reduce the threat to the computer.
Oh, I see.
In other words, it's
Okay.
just a protector.
So it is a policeman then. Yeah.
But we don't have anything here, right? I mean, no, we don't have any web server or anything. We just have the Bastion server because the web server is in another subnet. But
Which is what Chris was saying. Why not have the web server?
correct. So what we've seen so
in the
far,
public subnet?
what makes more sense to us is having the web server in the public subnet and then having a NAT gateway there for these guys to connect to the internet.
Mm-hmm.
And then having a security group in your web server, right? And then having a NACO in your subnet, right? But let's say that you have an application server here and you don't have a web server here. Then how are you going to protect this guy?
Yeah,
Then
you need, and then in that case, you need a Bastion server.
Correct, or the proxy server, right? Because a Bastion server is a proxy server, right? You see?
Yes.
A proxy server, right? So the other question is, should I use memcached or Redis? Okay, so you know, if your application is heavy duty, then you use Redis. If it is not heavy duty, then you can use memcached. Okay, for more, you can go here and see Elasticache.
I was looking at that.
And then here have Redis, and then here memcached. So you have the differences here, right? You see that Redis has more yeses than Elastic and memcached. Okay. You know, a multi-threaded architecture, different threads. Redis doesn't work, but memcached works. So you have to see this little table where they compare side by side and see which one applies more to your architecture. And then you know where to use one, where to use the other one. If you have transactions or replication or snapshots, then memcached is not the guy, right? It's Redis. Okay? It all depends. You know, it's working with database, right? They both support data partitioning. They both have some millisecond latency. They have both support for a broad set of programming languages. But then when it comes to advanced data structure, memcached is not good anymore, and Redis is the one. Okay, and multi-threaded, like I said before, memcached yes, Redis no, but then all these guys, then it's Redis. You see? You want to know more about Redis, then you can click here, and you want to know more about memcached, you can click here. Let me put it in the chat. That's the table, the differences between Elasticache for Redis. Over here, the benefits is fully managed and hardened. It means that it's very secure. Redis compatible. And by the way, Redis is a third-party thing. Elasticache is compatible with Redis, right? This is your Amazon Elasticache for Redis. It's a blazing, super fast, in-memory data store that provides sub-millisecond latency to power internet scale real-time applications. Built on open source Redis and compatible with Redis APIs, Elasticache for Redis works with the Redis clients and uses the Open Redis data format to store your data. Your self-managed Redis applications can work seamlessly with Elasticache for Redis without any code changes. Elasticache for Redis combines the speed, simplicity, and versatility of open source Redis and manageability, security, and scalability for Amazon to power the most demanding real-time application in gaming, ad tech, e-commerce, healthcare, financial services, and IoT. Tough guy. Okay, and you see how it works here. The good thing is that they both work with Amazon RDS, Amazon S3, MongoDB, and Cassandra. Cassandra is a third-party database. Okay. Okay. The other question is, what is the bandwidth used? No, what is the bandwidth of the AWS Direct Connect connection? Do we know? We don't know, but we know that it has a connection through Direct Connect. Right? So here we have the customer gateway, right? And this is the virtual private gateway. So for Direct Connect, we need two things: the customer gateway, which is the router here. When it says gateway, is a router. The gateway is a router. So customer gateway here and the virtual private gateway here, or VPG. Okay, and then we have the Direct Connect here. Remember, this guy doesn't traverse the internet, right? It doesn't need the internet. It's just through private links, right? Okay. So the wider the bandwidth, the faster it's going to be, right? It's like a pipe, right? The pipe is narrow, so the water will come through slower, right? But if it is bigger, it has more capacity for water.
Exactly.
So continue here. I think, do we have time for all the questions? I want to finish this. So we don't have the answer for these guys. I mean, the questions that we have here, we don't have the answers. It all depends on your architecture. These questions are not to be, all of them are not to be answered now. It's just for you to consider when creating an architecture, what you have to bear in mind. Okay. So another question is, what is the throughput of the DynamoDB instance? We have here, what is the throughput? How many write capacity units does he have? How many read capacity units does he have? So that's important too. What's the throughput? How fast it is, right? Another question is, does Amazon CloudWatch use the tail monitoring or the fault interval? So is he using 5 minutes or every minute, right? Does he have the tail monitoring or just the basic one? The basic, is every 5 minutes. The monitoring, the enhanced one or the tail one is every minute, right? You can go even lower. You can go to 1 second, 5 seconds. It's going to cost you more. It's a high resolution and monitoring, right? So this architecture does not use Amazon Glacier. Could the customer realize cost savings by moving some data off Amazon S3 and onto Amazon Glacier? Okay. We don't know if the customer is using Glacier, is not here, right? But that will be a good solution as well. If the data is not being used, the files are not being accessed, so you can move them through a lifecycle policy to Glacier. What is the cost of using Amazon CloudTrail versus the cost of node auditing? Okay, sometimes cost outweighs security, and people don't consider trailing because they want to save money. Okay, but security is super important. because you're dealing with someone else's information. So you better secure your infrastructure. And trailing gives you governance, auditing capabilities. So that's very important. Are you using trailing or not? That's very important. You have to enable it. Don't forget that. What is the cost of using Amazon Cloud Trail versus, okay, why does this architecture use two load balancers? Could Amazon SQS be used? All right. First of all, Amazon SQS is not for load balancing. Amazon SQS is for decoupling the infrastructure, decoupling, right? To make it more highly available, right? Two different things, okay? So it deals with messages, polling of messages, right? While SNS deals with pushing messages, this one polls messages. It means that it extracts the messages from the consumer and then works with that, right? So SQS is also used for serverless applications, and it's very good to safeguard your data, okay? So while the messages are in the queue, they are safe, okay? Your infrastructure can go down, you still have the queue, and the queue contains the messages, right? That's why it's good for decoupling, right? Other question is, why does this architecture use two bastion hosts? Okay. I was using two bastion hosts because you have two different availability zones, right? Okay. So we're working with this one and this one. Even though we can use one for both and one reverse proxy for both, we can use that too. But I don't think we need two. That's more money, right? And the last question is, could any of these workloads be done with AWS Lambda? What do you think, guys?
I think yes.
Of course, it can be done with Lambda. It can be done with Lambda because remember that Lambda is just serverless, right? But we have a problem. What is the execution time limit of Lambda?
15 minutes maximum.
15 minutes. If your application needs to run for more than 15 minutes, Lambda is not the service. Okay? So for that particular reason, we have an option. If you want to go serviceless, then we have something called step functions. And step functions can have several Lambda functions there through steps. Okay? That's for, that's for architecting, that's for orchestration of workflows, right? And it goes through steps. And then you can use Lambda, several functions there that last for 15 minutes each. And then you can work with that. So we have some links here that I can send to you guys later, but I think that you have that already. I think that I sent this on TCO and Billy Reports, Monthly Calculator Explorer. I think that I sent this one as well before, and this one too, right? Guys, if you check this, if you don't have this, guys, you can let me know later and I can send the link to you.
I don't have, let me see. Cost Explorer.
So the questions. How do you make sure your capacity matches but does not substantially exceed what you need? The anti-pattern is overuse or over-provisioning. And the best practice is what? Auto-scaling, right? Auto-scaling. Queue-based using Amazon SQS, right? And time-based using scheduling, okay? And that's gonna be appropriately provisioned, right? You're not gonna be under provision or over provision, right?
Mm-hmm.
How are you optimizing your usage of resources of I forgot the word here. Okay. All right, resources. And no, they leave a space. All right. So the usage of AWS services. Service-specific optimizations such as minimize input-output for Amazon EBS, avoid uploading too many small files into Amazon S3, and use spot instances extensively for Amazon EMR. So what is Amazon EMR?
Elastic Map Reduce.
That is correct. Is the industry-leading cloud big data platform for processing vast amount of data using open source tools like Apache Spark, Apache Hive, Apache HBase, Apache Flink, Apache Hudi, and Presto. All of these guys are third-party technologies, but this is a guide for big data. It's a bunch of big amount of data. Okay. Have you selected appropriate resources to meet your cost targets? Match your instance profile based on need, compute, memory, storage. Determine appropriate instance types using third-party products such as Copper Egg or New Relic. Company Corporation is a cloud computing system management company based out of Texas. Copper Egg Province is a family of software as a service-based cloud monitoring service for services for public and private cloud environments. Performance monitoring, okay? Determine processor load using Amazon CloudWatch monitoring. Load custom memory scripts and inspect memory usage using Amazon CloudWatch custom metrics. Profile your application to know which type of Amazon EVS volume to use, such as magnetic general purpose SSD or provision IOPS. Question 4, have you selected the appropriate pricing model to meet your cost targets? Use spot instances for selected workloads. That's one of the use cases of spot instances. Perform regular analysis of usage and purchase reserved instances accordingly. And factor in cost when choosing a region. Remember that cost varies from region to region. That's very important. And availability zone to availability zone. Automate turning off unused instances when not needed. You know that already. Sell reserved instances you no longer need on the reserved instance marketplace and purchase others. Guys, don't be surprised if you see that this is one of the solutions in one of the questions in the exam. Selling your instances. Okay, and where do you sell your instances? In the marketplace. Okay. Other managed services, high-level services than Amazon EC2, Amazon EBS, Amazon S3, you can use to improve your return on investment. Consider other applications. Services like Amazon Simple Queue Service, SQS, Amazon Simple Notification Service, SNS, Amazon Simple Email Service, SES. Achieve the benefits of standardization and cost control using CloudFormation templates, Elastic Beanstalk, OpsWorks.
A lot of questions on Elastic Beanstalk.
Yeah, because that's deployment. Deployment is very important. Consider appropriate databases, Amazon RDS, Postgres, MySQL, Microsoft SQL Server, Oracle, MariaDB, Amazon Aurora, Amazon DynamoDB. Okay, guys, basically they're telling you consider everything from Amazon, right? but you have to see which one is more appropriate for your architecture. Okay, so you consider all these guys, right? All these guys. We have Amazon EC2. We can consider Lambda. We say Amazon EVS. You can consider other, maybe S3, Glacier, whatever, all the types of EBS volumes, and all with intended to get a better return on investment, right? Saving money. That's very important. What access controls and procedures do you have in place to govern US usage? Establish groups and roles. You know that already, guys. That's one of the best practices of IAM. You can create an environment groups and roles such as development, test, and production. Use AWS governance methods such as IAM to control who can spin up instances and resources in each group. Track, measure, and audit the lifecycle of projects, teams, and environments. Okay. What are you monitoring usage? How are you monitoring usage and spending? Tagging. Remember tagging?
Lots of questions about this one.
Tag all resources to be able to correlate changes in your build to changes in your infrastructure and use. Tag allocation costs, okay? Or cost allocation tags, that's very important, okay? You can save money by tagging. Right? Have a standard process to load and interpret detailed billing reports. Have a plan for both usage and expanding in designing a cost efficiency architecture. Use AWS Cost Explorer. Guys, whenever you design something, we cannot do what we are used to doing. It's just go ahead and design. We have to sit and design before. The design phase of a project is crucial. You have to design with failure in mind. You have to design thinking that you might change your resources in the future. You have to design using parameters in a template, CloudFormation template, because you don't know if the key to SSH into an EC2 instance is going to change or other parameters are going to change. So you have to think, you have to leave room for improvement, for changes, for modifications. Always you have to design, always. And think cost all the time. Cost, okay? When you present a cost-efficient architecture and the owner, the business owner compares that with what he's spending right now, and you see that there's a lot of savings in migrating to the cloud, then the person can reconsider options. Cost is very important, right? So monitor usage and spend regularly using Amazon CloudWatch or third-party providers like Cloudability and Cloud Checker, okay? With those third-party solutions. Set up notifications to let key members of your team know if your spending moves outside of defined limits. So that's SNS. Use the finance-driven chargeback method to allocate instances and resource to cost centers, such as tagging. Tagging again. All right. Do you decommission resources that you no longer need or stop resources that are temporarily not needed? That's a good question. So design your system gracefully to handle instance termination as you identify. When it says gracefully, it means that you're not gonna end things abruptly. It has to be gracefully for things to fall in place and nothing be broken, As you identify and decommission non-critical instances, unneeded instances, or resources with low use. Have a process in place to identify and decommission orphaned resources. Orphan is that they don't have a parent, okay? They're not being used by anything else. For example, you know what an orphaned resource can be? An EBS volume that is not attached to any EC2 instance. That's an orphaned resource. It doesn't have a parent. The parent would be the EC2 instance. So decommission that, right? Terminate it. Take a snapshot first and then delete it. You don't need that, right? Reconcile decommission resources based on either system or process. So that, yeah, you know, a processor system, and then you decommission that. Question number 9. Did you consider data transfer charges when designing your architecture? What are you charged for when it comes to transfer? What do you guys charge for when it comes to transfer?
Size of the data.
I'm sorry?
Size of the data. They charge you as per the size of the data you transfer out.
Outbound transfer. Correct. Correct. Okay. So use the Amazon CloudFront CDN, content delivery network, and also when you transfer data to an EC2 instance or CloudFront within the same region, that is free as well. Right. Balance data transfer costs when you need with your need for high availability and reliability. Architect to optimize data transfer. Analyze if using AWS Direct Connect would save money and improve performance. You know that AWS Direct Connect it's not cheap. Okay, so you have to balance that out. See if you can afford it. I mean, based on the return on investment. How do you manage and or consider the adoption of new services? Meet regularly with your AWS Solutions Architect, consultant, or account team. Consider which new services or features you could adopt to save money.
I have a quick question about the marketplace.
Go ahead.
Do we have to register the account in the marketplace to be able to sell or buy? Or just once we have the account, it's already registered in the marketplace?
Not for buying. Okay, marketplace. Do you have to have a subscription?
I know that we have to pay some fee in order to sell the
You have to have a subscription.
Okay, so we have to subscribe.
Yeah. See
Okay.
all of your software solutions view, manage subscriptions, launch software. How does it work? From a breadth of categories, networking, and then buy through flexible pricing options. Bring your own license, free trial, pay as you go, hourly, monthly, annual, and multi-year seller private offers and consulting offers. Okay. Documentations. Seller guide, buyer guide. Okay. This is similar to, it sounds like eBay to me, but eBay has options. There's options here for spot instances as well. All right, so it's a curated digital catalog customer can use to find, buy, deploy, customer need to buy solution. I need as a seller. Go to the AWS Market Management portal to register. If you're providing a data product or you are charging for use of your software product, you must also provide tax and banking information as part of your registration. When you register, you create a profile for your company or for yourself that is discoverable on AWS Marketplace. Yeah, but I need to see the cost. You have to register.
Click on the portal link
You have
down
to.
below. Click on the portal link, right? No, up, right there. I'm sure they charge you something, right?
Let's see. So far, it's free. Let's say database. This is education. Registration complete. You can now start creating products for AWS Marketplace. We sent a welcome message to the email link. And then after completing your profile, you can offer some products. To offer paid product service, you must meet the following requirements. You must be a permanent resident or citizen in an eligible jurisdiction for paid products. You must provide tax and bank information. To submit this information, choose start. Okay, and then I can choose us out here. Tax interview. Okay. So far is free. Okay. But I doubt that AWS will not charge you a fee for every single item that you sell. I doubt that. Everything cannot be free.
Yeah, I think the setup to provide free products, it's free. When you start selling something, they're gonna take a percentage of it.
Yeah.
I wrote somewhere, I remember I was doing the test and I did to the cloud, it was one question. So I read that if you sell the EC2 instance, you need to pay some fee, but I don't know how much they charge you.
You pay the fee to AWS, right? When it's reserved instances. When it's not reserved, you stop it or terminate it. That's it. They charge you, I think they charge you like 25% of the upfront fee when you pay upfront. If you don't pay upfront, they charge you percentage of the cost of the EC2 instance reservation. But when you sell, I'm talking when you sell, just like you do with Amazon sales, I doubt that AWS will not take a portion of that sale.
Mm-hmm.
Probably 10% or probably 5%, 7%. I don't know. They have to make money. I mean, one way or another, right? And yes, it's just a platform to sell, right?
Professor, I have one question. I was doing also some of the tests in digital cloud. So one of the question was about the global accelerator. So, and I was missing that. Like my answer was CloudFront, but actually the real answer was global accelerator. So what was the difference between those two? Why we use the other one and not CloudFront?
Okay, what do you mean this one? The DAX?
For the global accelerator. I'm sorry, I don't know how to pronounce that well. The global accelerator.
It's a global accelerator. Yeah.
Yes.
Yeah, there was a question about that.
When we use that one and when we use the CloudFront, why we use sometimes that one and not CloudFront?
AWS Global Accelerator is a service that improves the availability and performance of your application with local or global users. It provides static IP addresses that act as a fixed entry point to your application's endpoints in a single or multiple AWS region, such as application load balancer, network load balancers, or Amazon EC2 instances. Okay, I can see the difference right now. AWS Global Accelerator uses the AWS Global Network to optimize the path from your users to your applications, improving the performance of your traffic by as much as 60%. You can test the performance benefits from your location with a speed comparison tool. Continue to monitor the health of it. Okay, I mean, this guy works with the applications. CloudFront works with Amazon S3.
Okay, now I understand. Because it was like a very similar, so I didn't understand which one
These guys work with Elastic Load Balancers and EC2 instances. The other one works with Amazon S3. So the origin of CloudFront is never an EC2 instance. Seamlessly with services including Shield, Amazon S3, Elastic Load Balancing, Amazon S3, auto origins for your applications, and Lambda Edge. Okay, this is new. They added more services. They added this. You know, guys, we have to be on top of this all the time because they're constantly changing and changing and changing.
In that question, I didn't see the differences between those two. So that's
Okay.
why I was like kind of scared. I don't know which one is the answer.
All right, let me see here.
I answered the same thing, CloudFront. I remember that question.